Thank you very much for coming here today to discuss the latest developments in physics, and particularly quantum physics, and how it could possibly define a new reality for us. Because as an individual, as a person living in this life now, growing up in the current environment that separates us as different nations, different religions, defines the reality as a separate reality. I remember my physics teacher in high school told me that I'm made of atoms, and that my atoms are totally different from at a distance, at a space, according to the Cartesian coordinates, from this table, from this chair, from you. So I see myself as this individual, disconnected, and totally separate from you, from the objects around me, from the space around me. And I see the state of the world, and I see that there's wars and conflict. And I start to wonder, what is the latest science telling us? What is reality? What is at the depth of reality? And what is physics telling us now?
Okay, well, the first thing I would like to say is, first of all, thank you for inviting me to come and talk with you. I wonder if, in fact, we find that science has given the wrong message to your teacher and to the world in general. And this message is that we are separate from each other, and that we really are treating ourselves as individuals, always interacting with each other, but we can always cut ourselves off from each other. And as you say, I think that particular paradigm always is going to lead to conflict. Because we are not separate individuals. Surely now we know that we're living in a planet which has finite resources, and what we do with those resources affects everybody. So that what we've really got in our society in general is, if we try and get a problem and try and solve it, we define a context in which to solve it. When we finally solve it, what do we find? We find we actually have new problems. New problems because they don't arise in the particular context that we've taken. We in fact are part of a global system. We are part of a totality. And whatever I do as an individual actually affects everybody else. And I think that what has happened is that in science, particularly the way we've given science to the layman, is that we have emphasized all the time what I would call reductionism. That is, we reduce everything to what we think are the primitive parts, we then put them into interaction with each other, and then we feel that that is the way the world works. That's certainly true for Newtonian physics. And it's certainly true that this Newtonian physics has been incredibly successful. It has given us the technology we have today. But the technology we have today actually is based on a very different physics. And I think people ought to be aware that there is a difference in this physics, and I think the difference is such that it says that this idea of getting things into their separate parts is no longer true. There's a new message coming out, not only in the physics but also in our society, that we do form a whole, and we've got to start thinking much more clearly in a more holistic way. Now, when one says this, one's got to be careful, because I'm always accused of being a new ageist, as it were, because it's very difficult to actually explain what one means by this holistic view. I think what I'd like to do with you is to try to bring this out and bring it out clearly as we go along, what is required and what are the problems in the way.
Yes, now, you see, for me the reality is what I see, what I experience and what I perceive. And what I perceive is that I am an individual, that I'm separate from the whole existence, that I'm separate from you, and as I mentioned, there's location, there's distance, and
Yes, but
And
what
the-
I would try and say is that because you're making that assumption, you're actually forgetting the fact that we are part of one total society, one total... You see, that what has happened in in our world is that we really what we were trying to do with our individual lives is to lead healthy, holistic lives. We want to be happy lives for ourselves and our families. Now, originally, the way we tried to do that was to make ourselves comfortable where we are. We invented religions. Probably man invented religions way, way back in prehistoric times. And the reason why he did that was to try to get his society together so that it was forming a coherent whole. But unfortunately, as it develops, as you well know, religions fragment. And you get a whole series of different religions fighting each other. The hope was that as we became more physically, more philosophically mature, we would find within our philosophy that we could build a society in which there was harmony. But what happened there again? It fragmented. And then finally, we went to science, hoping that science would make our lives much more holistic, would make our lives much more happy, would make us much better people in our society. But what happens there? It fragments again. And the fragmentation came in because of the tremendous success of the Newtonian physics, the Newtonian paradigm. Because we seem to think that what we want to do is just solve one problem after another and everything will be fine. But in fact, what do we find? As I said earlier, when we solve one problem, we find a whole series of other problems coming up. The conflict is still there. Even within little groups, conflict actually ensues. Now the question is, can we actually move to a way of thinking that does not emphasize this conflict? Because we depend upon each other. And therefore, without that, we're not going to live any harmonious whole. And we're going to have the same problems coming time and time again.
Yes, so you're saying already when I assume that I'm an individual separate from you and from that realities are all separate, disintegrated bits, you're saying that you already have an assumption, that is an
and
assumption.
that assumption is, I'm saying that assumption is something that we've got to question. Because if we don't question it, we're going to go on getting conflicts, we're going to get worse and worse conflicts, and the whole place is going to really, we're going to destroy ourselves with it.
Yes.
So let me try to explain how we might get some simple examples, some nice intuitive examples to see how we can begin to think and try and get a clear idea of what it is I'm trying to talk about. You see, one of the problems with the way we think about the world is that we think about ourselves as being outside the world. When we make our descriptions, we describe things that are out there, that are separate from us.
Correct.
So we're looking at it as if we're sort of a mini God looking down on the universe.
Yes, I'm looking at the star, I'm looking at you, yes.
But we're not outside the universe. We are inside looking out. And it's that attitude of inside looking out which is where this becomes important. In the quantum domain, for example, when we want to do our experiments, our apparatus actually is in participation with the process that we're actually looking at. In other words, we are participating in the universe, not looking at it from outside in an abstract way. And it's this point of view that we've got to try to get hold of. So we've got an internal relations, and we've got external relations. And we've got to get a relationship between the internal and the external, between the observer and the observed, as it were, between the individual and society, and so on. Now, one paradigm which one uses to try and get this idea across is essentially the following. There was a very nice little demonstration which consisted of a perspex cylinder with some glycerine inside it and a little perspex cylinder in the middle. And now what you do is you put a little dye of material in that glycerine, and then you wind the glycerine, the inner cylinder, and of course the spot disappears. But did you know that when you unwind it, it reappears again? Okay, so now we've got a different idea here. When we wound it and we said, the spot's gone, there's nothing there. In fact, there was something there. The something there has been enfolded into the background. And then when we unfold it, it suddenly reappears again. So what I'm trying to get at here is that there's a deeper world which is not outwardly manifest, but is nevertheless acting all the time. There is a kind of an inner structure which has not been made manifest. Now, David Bohm had a particular word for this. He called this the implicit order. That is the order that is implicit in the total process, of which the parts were the external order, which was the explicit order. So you had this continual unfolding of the implicit order, rather than particles moving along trajectories, fields evolving in space and time. You have a much more different way of looking at how processes go on in nature, of this unfoldment. Then you can begin to see that if the structure is enfolded in this way, then you begin to see, remember the classic two-slit experiment? Shall I talk a little bit about that?
Yes,
in
please.
quantum mechanics?
Yes, please. Yes.
Because there we have two slits, in which we allow particles to go through that slit. When we collect the particles on the screen, we find it looks like a distribution as if a wave was going through. We did exactly the same properties as a wave. What is more important about this thing is that if I shut one of the slits, the pattern is totally different. In fact, the interference pattern disappears. Okay, now let's go down to the level of the particle. Think of yourself as an electron, and you're coming up to this two slit. Now you will go through one slit or the other.
That's right.
But how do you know whether the other slit is open or closed? It's a bit like driving your car through the Alps, and there are two tunnels separated by something like 200 miles. And you're going through one of them, and where you end up depends upon whether the other one has got a blockage in it or not. Now that's quantum mechanics. You have to understand how that particle going through one slit knows the other slit is open. Now then, suppose you take the model that I've just suggested of this folding and unfolding. Now, can we see what could the electron be in this case? Normally we think it's a little billiard ball. You've been telling me we play billiards in physics. Suppose it's not a billiard ball, but it's like this molasses experiment that I've been talking about. Namely, you see, we don't see electrons. What we see is a trace that they leave behind in a cloud chamber, or in a bubble chamber, or in a photographic emulsion. So what we actually see is a series of dots. Now think of this molasses experiment I was talking about. And as we unfold it, one dot appears, we go on, it enfolds, and then another dot enfolds. So the energy is actually going through a periodic motion, so that it goes out into the total space and then comes back again, out and back again. Now you could begin to understand how you could understand the two-slit experiment, for example. That the electron is not something that is local, but has a large domain of activity in it. And therefore, it knows, as it were, that the other slit is open because of this unfolding, enfolding process.
Because it goes to a background that
It
has
goes
the whole.
into the background and then re-emerges from the background. So we get an entirely different way of looking at the way things unfold in nature.
So electrons flick? Do they flick? Back disappear into the
No,
hole
this
and come back?
must be very clear. This is a model I'm talking about.
Yes.
But this is a model which would account for this.
Yes.
And in fact, David Bohm and I published a paper in which we showed how you could get the equations of motion out of this very type of process. That the electron would go into the implicate order, and then would re-emerge as an explicit order and then enfold back into the implicit order, so that the movement is totally different now.
Now, we know that electrons change orbits and give off energy and receive new energy. But the interesting thing is when they change orbit, they're nowhere in between. They don't travel. Am I correct in assuming that? They don't travel from one orbit to the other.
That depends which model you're using.
I'm
Okay.
talking about, I'm a layman.
Yeah.
I'm talking about the real. What do we see when electrons give off energy, and do they travel between
Well,
orbits?
we cannot see the electrons travelling from one orbit to another. Just as we cannot see the electrons going through this bubble chamber. All we see are the bubbles. It's like looking up at an aircraft. We don't see the aircraft, but we see its vapour trail. And then we assume, aha, that's an aircraft causing it. Fortunately, we have seen aircrafts on the landing stage, so we know what they are. But no one has actually got hold of an electron and said, look, here's an electron. Okay? So now we've got to use our imagination to try and understand what is going on. So my answer to you is, we don't know what an electron is, and we can't see it jumping from one energy level to the other. Okay? Now, does that mean that there is not an electron jumping from one energy level to the other? This is the question.
But we see the spectra of...
We see the light that it emits when it loses the energy.
Yes.
So we see the effect, not the actual process.
Is it because it's too small to be seen? Our instrumentations fail us?
Well, our instrumentations are going to fail us because not just because they're too small and we're disturbing it, but the actual order of the process is totally different from the order of process one would expect if it was a Newtonian process. You get my point?
Yes.
It's a entirely different process of folding and unfolding. There is no trajectory. There is a folding and unfolding.
But the way I understand this unfolding is it goes into a wholeness, so it disappears.
Yes, it goes into the environment, into the background.
It goes into the background.
Yes.
That means it disappears from this explicit
Yes.
order, what we see now,
Yes.
explicit.
Yeah.
And it comes back.
And it comes back
Which
in.
means to me, if you look at it, it's like flicking, isn't it?
Well, if you want to call it flicking, fine.
So are we
But
all
flicking
flicking?
is more like, flicking is more like this
No,
when you
no,
flick
no.
a coin.
No, sorry.
Flickering.
Flickering.
Flickering. Yes, you could think of it as flickering.
So we are flickering. Me and you, are we flickering now?
Very, very rapidly. So rapidly that we can't actually see it happening.
You talked about the fact that at the micro level, at the subatomic level, it is the wholeness that defines the parts. Now, I know from reading just a general, out of curiosity, that Einstein was looking at the extraordinary macro level, at the very high distances and velocities of light.
Yeah.
Was there any such field in his findings?
No, he was very much against this particular. I mean, it's known as the Einstein-Rosen-Podolsky effect, or paradox. Although the experiments have only been done from the 70s, 80s and 90s, the actual effect that I'm talking about was brought to our attention by Einstein himself way back in the 1930s. And he felt that this meant that there was something very wrong with the quantum theory. Because he did not like this idea of what he called its spooky action at a distance. For him, the world was a local place where nothing could move faster than the speed of light. And therefore you have the traditional, what I call the Newtonian view again, where you have separate entities and they can be, the way you connect them is by means of electromagnetic forces. So he was very much against this, and in fact he refused to accept quantum theory because of this non-locality. Now it was Niels Bohr who said, no, but we have to accept this non-locality, because that is what the formalism in quantum mechanics is telling us. And what Einstein said was, well then the formalism of quantum mechanics cannot be complete. And there has been a whole history of trying to complete quantum mechanics.
So Einstein was never happy with quantum mechanics.
As far as I know, right until the end, he was not happy with quantum mechanics.
What about his fields? What about his own relativity theories and all that? Were there fields that... Was there wholeness in his ideas as well?
There was, in a way. I mean, well, let's get this idea of the field across first. The fields that he was using were fields that would propagate with the speed of light. So if you had your field produced by an electron, say, charged particle, and then you oscillated that electron, it had a field around it, and that field, that oscillation of that electron would disturb the field, and that disturbance would then travel across space at the speed of light. Okay? Now then, there was another idea that he felt that he had put into his general relativity. This is a different idea. And that is what is sometimes known as the Mach's principle. And Mach's principle said that the actual inertial mass of a particle locally depends upon the distribution of stars in the universe, or distribution of masses in the universe. Now there's always been a big debate, does general relativity actually have Mach's principle in it or not? I have never been happy that it's been answered one way or the other. But certainly you were asking me about what Einstein thought, and Einstein certainly had that as a motivation in the back of his mind, that there was a kind of principle which unified the cosmos. But he didn't, ironically, like the quantum non-locality.
Because it's very non-intuitive.
Sure, because what has happened is that we have developed this intuition. We have learnt our physics from childhood, and our physics has been reinforced on us in our everyday life that things are separate.
That's right.
If I want a glass of water, I have to walk across somewhere and get it. It's not part of me. But what I'm saying, that if you want to get really down to the deep underlying reality, it is not separate entities. And I feel that getting down to the deep underlying realities is the way we're going to get out of the mess of conflict and fragmentation.
But this requires a substantial change in the education, in what the scientists, the messages that... what I'm trying to understand, why is this not communicated? Why am I still graduating as a high school graduate or even university graduate? All I know is how to compute what a billiard ball will go, the speed it will go and hit something and come back. Why is this new reality not communicated?
This is a very good question, and I think one of the problems has been that there has been a big dispute over the interpretation of quantum mechanics. And it's in that dispute that people don't quite know what message we should really take from the quantum phenomena. And I think this is the main problem. And while that dispute was... Because I remember John Searle, who's a famous philosopher who thinks a lot about mind and consciousness. He said to me once, he said, Basil, when you physicists guys have sorted out quantum mechanics and give us a coherent, comprehensive answer, I will then begin to consider whether quantum mechanics plays any role in consciousness studies or not. So that's one problem. The other problem is that I think people are frightened of wholeness. As I told you earlier on, I made a remark that when you're talking about wholeness, you're getting into holistic ideas. And holistic ideas have got a very bad press, because somehow it's sort of weird spookiness. And what I'm trying to say is that one of the reasons why we can't get a good understanding of wholeness is because we've not really thought about it carefully enough. And I think, and in fact it's very difficult, because our experience, as you say, is that we're not connected to each other, and yet basically we are deep down. And it's really getting to those depths that we've got to start thinking again.
I still find it amazing that the fact that we've done so much with quantum theory in our technologies that are coming, and I would be very happy if you later on tell us where, in which areas we use quantum theory. So technologically we're using it, it's amazing. But what quantum theory is showing us as a new face of reality, it's a great revelation, it's a great insight that could possibly bring us a totally new way, a new state of mind of living together.
Well, that certainly was what David Bohm had in mind, for example. As you know, I've worked with him for over 30 years, and he was very much trying to develop the general philosophical scheme in which we could discuss this notion of wholeness, where we could change people's attitudes and try to, but it's not something that you can do overnight, because it's very difficult. I cannot tell you, if you think this way, you will be thinking holistically. Unfortunately, it's something which we're having to develop as we go along. And I wonder if I should, at this stage, bring in some ideas which might help.
Yes, by all means, please. But again, coming back, if I'm made of cells, let's say organic cells, and if cells are complex molecules which are atoms by itself, if I am a different entity than this, than you, then how can I question that reality? What does reality say? What does latest science is saying about the subatomic world? What does it say about?
Well, the subatomic
connection?
world in the quantum domain has got some very difficult lessons for us. One, I'm talking now, of course, about quantum mechanics, quantum theory. Now, quantum theory was forced on us, and we can discuss why it was forced on us in a minute. It was forced on us because our Newtonian physics did not explain much of the material process that's going on around us. We found it very, very strange indeed, and we were desperately trying, and people have been desperately trying for over 100 years now, to make a Newtonian type explanation of quantum phenomena, and it fails. What we have done is we've gone back and relied on the mathematics. We said, oh, the concepts don't matter too much. Let's just be with the mathematics. So we're playing with abstract mathematics. But if we look at that abstract mathematics much more carefully and try and synthesize from it what the world view is, we find we get something which depends upon wholeness. That we must not subdivide systems into independent parts and put them into interaction together. We can't do it. Quantum phenomena is saying, no, that's not possible. So here in nature, we have a kind of holism already there. And this idea of separation is not the right way of dealing with things.
So you need that connectedness as a part of the mathematics, or as you need that as a...
You need that concept in order to understand quantum phenomena. If you don't do that, then it becomes quite crazy. You get, you know, the stories about what I call the schizophrenic cats, who find themselves in a box, both being in a state of alive and dead at the same time. Now that's happening because we're trying to analyze it into separate parts, instead of trying to analyze it in terms of a total process. And this is what we've got to try and move towards, this total a way of looking at things where we don't subdivide, basically.
So at the very, very minuscule level of subatomic world, it's the whole that defines the parts.
Absolutely, and that is, in a way, the organic way of looking at it. See, that the human beings are organic, animals are organic. In fact, our planet is organic. In other words, we need to see how the different parts interfere with each other. Even more than that, that the individual parts are actually abstractions from the whole. And this is the type of idea we've got to get hold of.
Now, about the environment, I can understand that. If I pollute the environment, it's going to come back to me with bad weather and warming and all that. It's going to melt, and I'm going to be, my cities are going to vanish. But coming back to the reality, to the atom, to the electron, where does this field, is there a field there? What is it that unites this? What is the unification, the wholeness? Where does it come into the picture?
It comes into the pictures in various places. I think the first man who recognized this, and I want to give recognition to this, because I have a view which is always thought to be anti this man, namely Niels Bohr. I feel he had a very deep perception of nature when he was talking about quantum mechanics. He used the word wholeness on several occasions, that somehow you cannot, when you're doing an experiment, you cannot separate the environment from the particles that are in that experiment that you're doing. It's more than that. It's that it's not possible to separate the two. That the system and the environment form a totality which cannot be subdivided further.
No,
Now
this is something I can't understand. You see, at this level, I can put up an apple, slice it into pieces as I want to. What do you mean by the observer, the experimenter being...
First of all, remember, Taher, that in the macroscopic world, subdivision is paramount. I mean, that's the way we live our lives, okay? And we live our lives because we're in the macroscopic world and we're concentrating on that. And we also think that's the reason why we should do that from Newtonian physics. This is my point. Now, what I'm saying is that when we get down to the quantum mechanical level, we cannot separate in this way. It's just not possible. Now, how do I get this across to the layman? This is the difficulty that I have. Maybe I should just say a little bit about these entangled states that people are really been excited about in the last 20 years or so. There's a situation that you can develop in quantum theory where you take your two atoms, I'll call them atoms rather than getting them complicated with other types of physical processes, and I can put them in what I call an entangled state. That's something I do to them that fuses them in some way. I then take the two atoms and allow them to move apart. Now what I find is when I start to play with this one immediately responds to what I'm doing here.
That is, there's no time...
There's no... Now, you say there's no time. We have done experiments which say that we have a finite time for our experiments to resolve, to produce the results. In that time, there is no time for a light signal to go from one particle to the other. Now, why am I emphasizing the light signal? I'm emphasizing that because, according to relativity, the fastest way of communicating is always at the speed of light. From relativity, it says you cannot communicate faster than the speed of light. Yet, at this level that I'm talking about now with the entangled states, we've done experiments which show, and I'm not talking about little tiny centimeters, I'm talking about kilometers, where experiments, when you do something here, you find that the response will not allow you to have any signal flowing with the speed of light. In other words, you separate something, let's say by 6 meters, but in the time that the experiment is done, light can only travel 30 centimeters. So that means these two things are totally separate spatially, but they are united by this new feature of the quantum force.
That's amazing what you just said. It's amazing. So something, so it's not, it can't, light can't, so there can't be signaling or communication process.
No, that's the whole point. This is what makes it really very difficult to understand. There is no possibility. I mean, the experiments have now confirmed this. It's well known. Now, let's take it a bit further. This means that if you have a whole series of particles, atoms, which are in these entangled states, then they behave as a whole. Now, that is the primary way quantum mechanics work. What happens is if you raise the temperature or if you interfere with it in some way, you can then break it apart. But basically, it is always forming a whole. It is only when we break it up that we get this fragmentation. So basically what I'm saying is that nature is telling us that at the very basic level, there is a kind of wholeness which we have not fully grasped yet. Because in our macroscopic world, like you're saying, everything is separate, surely.
Absolutely. Yes.
And what this is saying is no, no, no. It is not separate. So there is something else involved. Now you take this with the philosophical ideas that people have had, that really we do form a whole. In our environment we see that. In fact, in our own bodies we form a whole, although we're composed of individual atoms, molecules and so on. Unless there is that, I don't know what to call it, that wholeness, that rhythm, we will no longer be humans. We'll die. I mean, that's the whole point. Conflict, and we die. So that when we say we want to be healthy, we want to make ourselves whole as individuals. And the wholeness, remember the idea of...
What you're saying is that the physics that I know, that I've been taught in high school, is relevant only at a certain range of reality. That when the scientists wanted to look at the atomic world and how understanding the structure of atom and how electrons and how stable it is, they had to define new. They had to be searching for new laws of physics. Is that what you're saying?
That's absolutely correct. That's absolutely correct. Now, one of the things that I want to point out and make a very strong point about, and that is, it looks as if all this comes from the very small, because we're chasing down to the atom. But remember, and therefore people say, a lot of people have said to me, well, what's the use of quantum mechanics? What's the use of quantum mechanics?
Absolutely.
It's all to do with the very small. But actually it's not to do with the very small. Because, as I say already, yes, it's the very small, but it explains the macroscopic world we live in. So without that microscopic theory, we would not be able to account for the solidity of
So we can't ignore it.
So we can't ignore it, no.
It's part of the reality.
And it explains why the spectrum of the sun is the way it is. It explains why we can have X-rays and things like that. It explains why these cameras and televisions and computers work. Because without the quantum theory, they wouldn't work. So you've got this classical world not existing in its own right, but resting on, as it were, this mystical, as you called it. But it's not mystical, it is the fundamental reality upon which it is all based. So you've just taken, or we've just, sorry, I don't want to insult you, we've just taken the macroscopic world and saying, well, I'm familiar with that, that's the way it must be. And what I'm saying is no, that is not the way it is. That's not the way it is from the way this quantum theory is telling us. We have to have a very different paradigm, and I think this paradigm actually comes up and affects us in lots of ways. Perhaps I should move on a bit, because, as I said earlier, you wouldn't exist without quantum mechanics, because it's the structure of quantum mechanics which gives your molecules form, your molecule substance and stability. But suppose we try to go into the brain. Now we've got a very interesting question. How does matter think? I have at the very lowest levels atoms, molecules, which seem to be totally inert, totally without any kind of animistic forces at all. And yet, when we look at our brain, and now we can look at it because we've got lots of quantum devices to actually look at the cells in our brain, tomography and so on, all depends upon quantum mechanics. And we begin to see the pattern, the neurons working, we begin to find which regions of the brain do what and so on. And it all seems to be material process. So what suddenly makes us think? And we know matter thinks, because I'm going to raise my hand. And by thought, I have actually produced an action of raising my hand. So the question then is, how are we going to understand the relation between mind and matter? Now, one of the ideas is that maybe the quantum domain is already beginning to show us a way in. That's the thesis that I have been exploring. Why do I say that? Well, first of all, let's think about the observer and the observed. One of the problems with the foundations of quantum mechanics was that one of the strong features of science, particularly traditional science, was to keep the observer out. The subject did not come into physics. It did not come into chemistry.
Which agrees with my understanding.
Which agrees with your understanding.
Yes.
Okay. Then we get to quantum mechanics, and suddenly we say, I want to keep the observer out of quantum mechanics. I want my explanation to be independent of the observer. I can't do it. Because we actually, this goes back to the idea I was trying to get across before, we are participating in nature.
So,
Whereas we're not passively sitting back and saying, oh, what a nice nature that is. We're actually saying, I've got to get in there, I've got to dig out this, and by doing that, I'm actually changing. I'm changing the process I'm looking at. And I cannot reduce that change.
so the scientist that is doing the experimentation, his involvement, his intentions and everything changes the experimentation?
Yes. Now, we've got to be careful. It's through his instruments of a proxy observer. It's not him subjecting anything. It's the fact that he's arranging the apparatus in such a way, and the apparatus is participating. Okay, so if you think about the apparatus, the observing apparatus, as the observer, then you find it's participating.
But one would say maybe those apparatus are disturbing the system.
No, it won't work. It doesn't work. God, we've been trying for 40, 50, 60 years to get an explanation using the disturbance hypothesis. And we've all failed. We've all found it doesn't work. We cannot do it. So either we say, oh, well, we haven't looked hard enough, in which case we carry on with the old, getting into the same old mess, or we say, no, we've got to stop. We've got to stand back and think again. But the point I'm trying to make is that we've tried to keep the observer out of quantum mechanics and we can't. So there is no separation between subject and object. Now,
So you're saying the electron knows it's being watched?
in what sense are you going to use the word knows?
When there's a watch, when there's an apparatus that is watching it, does it change the system? Does it
It
change
changes its behavior.
So
yes.
it knows, and it knows.
I wouldn't like to use the word knows.
In quote, knows.
In quote, yes.
In quote, knows.
It feels the
It
apparatus.
feels. So,
But not in an interactive way, in a much more subtle way.
so we are inside this reality, and the things we do, the reality is responding to us.
Yes,
There's an interaction.
The basic entities that we're trying to attribute independent existence do not exist independently. You cannot separate them off from the rest of the process that is going on. That's what quantum mechanics tells us. Everybody agrees with this. This is not something...
This is not you
this
saying
is not
that.
me saying.
Because here I'm sitting, I'm saying,
no.
I'm speaking to a very respected quantum physicist.
Who actually does theories which are the opposite of what I'm advocating now. And it's because they failed that I can advocate this much more strongly. You with me?
Yes.
And I'm really repeating what Niels Bohr said, but nobody believed Niels Bohr. That you cannot separate the phenomena from the means of observation.
There's a wholeness that cannot be broken.
There is an inseparability which cannot be broken.
We're part of it.
Yes. Now, at a certain level, of course, it can be broken, because we can detach ourselves from our apparatus. But fundamentally, there is this wholeness. And it's only at a certain stage that it becomes fragmented and individual and so on. And now what I was developing was mind and matter.
Yes.
We've separated, we can't separate the observing apparatus from the process. Now, can we now separate the mind from matter? Or is there an inseparable link between mind and matter? In other words, is there some deep connection which we have to try and understand? Not how the things work, but how we understand how mind and matter are related. And we had this idea of going to the implicit-explicit order idea. That what we're doing is, in our experiments, is we're making something manifest. Okay? This is what our experiment's about. We're looking at an implicate order, and we're manifesting certain features of that implicate order.
This implicate order that has the whole of reality, cosmos in it. The mind
is part of that.
The human mind is part of that.
The human mind is part of that.
That means it's possible to penetrate into that. It has the possibility, potential, to go into that level of depth.
Yes. And that's what our thought processes actually do. Perhaps I should try and bring this out a little bit clearly by
Yes,
thinking of
please.
some example.
Yes, please, because at this level, when I'm thinking of me,
Yeah, okay, but
separate than you.
yeah, but don't think about you and me.
Yes.
Keep them separate.
Right.
I want you to go into your own mind. And I want you to recognize in your own mind that you have neurons dancing around up there.
That's right.
Okay?
That's right.
Yet you have this other, all these ideas
Yes.
going around.
Yes.
Are they separate from your neurons? That's what you want to say, if you're Newtonian.
Yes. Yes. Sure.
Okay? But then how do they interact? Where is this mind which you... Okay? Now, suppose you do the following. Suppose you say, no, well, let's... You were taking the analogue of the electron. You were saying, does it know? And I kept saying, no, you mustn't talk like that. Let's take that a little bit further. Because what we're doing in the brain now is saying, does this neuron know what you're thinking?
Yes.
Okay. So we've got to develop one more concept which I haven't developed yet. Can I do that? Can I
Yes,
go on to
please.
this new
Yes,
concept
please.
and then
By all
come
means.
back again?
Sure, by
Remind
all
me if I
means.
forget.
Yes.
When David Bohm and I were looking at quantum theory from the point of view of his particular point of view, which is called the Bohm model, what we found there was that there was an additional potential which comes in. That is not only additional form of energy. Let me put it a different quality of energy. There is the kinetic energy, and that's the energy you experience when you're
Sure.
sitting in a car. There's the classical potential energy, which is the electromagnetic force on electrons and so on. But then what we find coming out of Schrödinger's equation is another term which we've called the quantum potential, which is a new quality of energy. Our original idea was to think of that quality of energy as kicking the football around, only a different kind of kick, yeah, moving the electron around. But the more we studied what the implications of that potential are, the more we began to realize that it wasn't a force of the classical nature.
It wasn't a force.
It wasn't a pushing force.
Yes.
It wasn't a efficient cause, as the philosophers would say. It was much more subtle. It was much more Aristotelian in the idea that it was a kind of a formative cause, that it gave form to the process. So if you think of the electron going through the two slits, the quantum potential would give form to the particular process of electron.
You mean guiding it?
Guiding, yes. Only a little bit more subtle than guiding, but guiding is a good thing to get hold of in the first place. So it's guiding it through. And in the non-local, what is it that's responsible for holding these two separate particles? It's the quantum potential again. So now you see why, and one more point, in the classical world, there is no quantum potential. The quantum potential is zero. So we now have the possibility of a continuous movement from classical to quantum without a sudden disjoint idea which we see in all the textbooks. Because it's when this quantum potential is negligible that we can isolate everything. But when it's not negligible, so it is the thing which is responsible for, if you like, for forming the whole. Okay. So we've got this idea. But we wanted to do one more, take it one more step. It was putting form into the process of the electron going through the two slits. It was informing the electron. So it's a kind of information potential. And if you look at the potential, you find that it actually has the parameters of the environment in it. So it's feeding in the environment to where the particle is. Okay? So what seems to be, and this is our speculation now, make it absolutely clear, David Bohm and myself. Whether other physicists agree with this or not, I don't know. They don't talk about it because I think they don't agree with it. Even though they want to put information in, they don't want to take this idea up, and I want to take this idea. Okay? Are you happy with that?
Well, it's very difficult to imagine that a particle that you cannot observe, it's so small, no matter how, with the latest, that you can't see it, that particle is able to understand, receive this information, analyze and say, aha, I know now. It's very difficult to imagine that.
But because you're trying to give it a human form. I'm not giving it a human form. It might have a proto-consciousness, I don't know if you want to call it that. What I'm trying to say is you look at the mathematical. You look at the mathematics.
This is what mathematics says.
This is what the mathematics could be saying.
Could be saying.
Right? And it's saying it in a way which I think makes sense. That we've got a new feature acting. Not only does energy push and pull things, there's also a more subtle energy that guides things.
And this subtle energy becomes significant at the small level, at the micro level.
So if you think 40 kilometers is a small level, yes. It works over 40 kilometers. That's where that non-locality has been experimentally tested. 40 kilometers.
No, I meant by the effects of that are significant at the micro level. Because at the macro level, obviously, I don't have quantum potential between...
No, because it breaks down. Its quantum potential is zero. It's cancelled out.
Yes.
Okay, so at that level, yes. But you can, if you confine it in subtle ways, you can make it still cohere over kilometers.
Because there's all these people who say, well, you can actually read each other's thoughts and all this parapsychology and the stories they built around it, that look, you know, if electrons can talk to each other at 40 kilometers, I can talk to you at 40 kilometers.
Okay.
They make all
Certainly that opens up that possibility, and that's why I said people get scared of it, because they don't want to be associated with these guys who claim that they can bend spoons and so on and so forth.
You're saying it gives a possibility, but not an...
It opens up the possibility, but please, we've got to do some science on it. My feeling is, first, let us understand what I would call normal mind-matter relations. In other words, what is going on inside the brain,
Yes.
without bringing in these other ideas which may or may not be true. I think they're all red herrings.
Yes.
We have very little evidence, although it depends who you talk to. Some people are very convinced, telepathy occurs. I don't know. I mean, when you try to do experiments on it, they always seem to be a little bit dubious for a physicist. Anyway, for me it's saying, let's put those aside. Let's think more about what is going on in our own brains when we're talking about normal thought and normal brain processes, if there is such thing as normal. And then we find there that we've still got this problem. Look, we have quantum mechanics telling us that, if you believe us, that information is becoming active.
What do you mean active?
It's becoming active. In other words, what do we mean by information? Information is something which actually makes people do things. For example, if this camera guy suddenly said there's a fire in here, what are you and I going to do? We're going to get up as quickly as we can and run. Right? So he's given us some information, and we have made that information active in us. So at the human level, certainly information is active. And what I'm saying is that I'm suggesting that even down at the level of the electron, there is information processing going on.
So there's a field, a unified field.
There's a field which is to do more with subtle features of information.
Now, Basil, we talked about wholeness, that at the subatomic level, at the basic fundamental level of reality, that we've got to put that into account. Otherwise, we can't explain the phenomena of electron and this. But still, I fail to understand what wholeness is. Is there any technology, is there any example in real life you can give me which explains this idea of wholeness?
I think there is actually. There's one particular image, metaphor, call it what you will, of non-locality, and that came in with the hologram. In fact, that technology was just developing as we were developing these ideas, and we actually took hold of the hologram and said, oh, look, this is a beautiful way of explaining what it is. Because remember that when you make a hologram, what you do is perhaps I should not go into it technically, I don't know. You can shine light into the object. You've got two signals. Let me start again. You've got two signals. You've got a signal coming in directly off the object, and you've got another signal, which you then overlap these two signals, make them develop a photographic plate, and you find that you've made a hologram. And when you look at the hologram, when you look at the piece of the plate, the photographic plate, you find that it just consists of a whole series of rings.
Ripples.
Ripples, ripples, ripples.
That's all I see.
That's all you see. There's a nice picture of one that I've got. You can see these ripples. But when you now put the light back through the photographic plate,
Shine the light.
shine the light through it, you see reconstructed the whole of the image that you've taken. Okay? Nothing remarkable about that. But if you cut it in half, take that half, shine the light through it, you'll find you'll see the image again. The whole image.
For example, it's an apple.
It's an apple, and you will see the whole apple again, even though you've cut the photograph of the negative plate in half.
So there's a plate, when you shine a light through it, there's
Right.
a whole apple that comes out of that picture
Yes.
as a hologram.
Right.
Now what you're saying is, if we cut that plate, that source,
In
in
half.
half, my apple doesn't get half.
No, you see the whole apple again. If you cut that half of the photographic of the negative plate again, so you've now got a quarter of it, you look at it through the light, you see the whole apple again. You do not ever cut the apple in half.
But
in other words,
yes,
all the information about the apple is stored everywhere on the plate. So you don't have normal films. You take one part of the apple, it goes through the lens system and impinges on the photographic plate and leaves a mark. So that if you have a normal lens system and you cut the plate in half, you will see half the apple.
that's right.
Okay? But in this case, no. What happens is information comes from the whole apple and is spread everywhere on the plate. So you can reconstruct the apple from just a small portion of the plate. And this is very much like the idea that I was trying to say, that when the process gets folded in the implicate order, the information about the whole process is in a very large region of space. So it's like the unfolding, enfolding is very much like a holographic movement. And this one idea, by the way, is where Carl Pryzdia actually suggests that maybe in the brain we actually store information in a holographic principle.
That is, information is not stored here,
It's not stored
there.
locally on a local magnetic drum, but it's stored all over the place, and we dynamically recreate the memory through the neuron processes. But here we have a very nice example how we have local relations mapped into the whole. So this means locality is not absolute. You see, one of the things that built into the Newtonian paradigm that even Einstein couldn't get over was that locality is absolute. That is the feeling, that locality is absolute.
That's right.
The hologram shows that no, locality can be a relationship. Because all the parts of the apple, the neighborhood relations of the apple, the local environment of the apple, is mapped onto every bit of the hologram. So that when you only use a little piece of the hologram to recreate the image, you still see all the local relations, i.e. you see the apple. So you've got locality in a relational way, spread all over the photographic plate.
So coming back to the picture of reality, can we say the apple is the explicit order, three-dimensional picture,
Yeah.
and in the implicate order, this whole, it looks like a long distance from here to there. It's a whole apple.
Yeah.
It could be a much larger picture. In the implicate order, which is the plate, this whole is recorded in one point, in one cell, in one
every
dot.
region, every region.
Every region,
Yeah.
yes.
Now you must remember that as you cut the picture, as you cut the negative smaller and smaller, you lose definition.
The
Doesn't-
detail.
You don't have, you lose the detail.
But still the whole is there.
Still the whole is there. Now that is an example of what we're trying to say is happening in the quantum world.
So me and you, in this three-dimensional world, we're quite separate, space-wise.
Yes.
You're saying it's quite possible that another level of reality, we're
Yeah.
all coming
We all are.
enfolded into one.
Yeah. Yes. That's something to.
That is
something
quite
to think
revolutionary.
that's something to think about, isn't it?
I can't imagine a more fundamental knowledge that has the potential to wake us up. Physics have played a very important role in politics by the atomic bomb and all that. And I think physics, the science of physics now has the potential to wake us up if we listen to it.
If we
really.
listen, the biggest problem is, will people listen? Because it is so strange that it's taking a long time to get used to it. But that is, that is a very nice metaphor for what it is that we're talking about.
So everything we see here, this huge space between here and the galaxies, could actually be an unfoldment from one region, from one space or whatever, at another level of reality. There could be actually no sort of distance. Everything is enfolded.
Yeah, yeah. And that's why, with the non-locality now, you begin to understand that why there is not a problem. Why there is a problem in the first place is because you believe locality is absolute.
Yes, because you're living in that 3D world.
That's right. And you see these things as separate, and surely once they're separate, they're independent.
And light cannot travel
And, yeah.
faster. And where is this connection is coming, this non-local? But at
Connection.
another level, there is no
separation.
there's no separation.
So if you think about the hologram idea, then the information about this particle is already here.
And you talked about the brain, the possibility that the information is actually registered in every part.
Yeah, because one of the big difficulties that people had with memory is finding where the memory is stored in the brain. And it seemed no matter where you tried to find it or cut the brain, the memory was virtually unimpaired. Okay, you lost a bit of detail, but the whole memory is still there.
What about examples in nature? For example, every cell has the information to the whole body through the
Well,
DNA and...
There's certainly a feeling, and perhaps one ought to go a little bit further with this particular example you've given, because one of the things that you expressed surprise at was that information is now active in the electron. Okay?
Yes.
Let's go to DNA. What we say is that the information is stored in the DNA, that the RNA molecules come up, process that information, and then take it to the cells, and then this gives the information to the cells, and the cells then start adjusting appropriately. But there you have a classic example of information actually working actively. So I don't know whether that helps you
Yes.
in
Yes, absolutely.
As biological beings, information is actually operating actively all the time. Now, John Bell, he saw that Bohm could do the impossible, but then he also noticed the non-locality. Then he said, "Yeah, that's interesting. Will all theories that try to reproduce successfully the statistics of quantum mechanics, will they be non-local?" And he managed to prove that if you had a local theory to produce the same results as quantum mechanics, it would satisfy a certain inequality, known as the famous Bell inequalities. Okay, now we've got a nice criterion. The cry was, let's do some experiments. At Birkbeck College, at my college, we had young David Butt and a couple of colleagues. They set up to see whether there was any change in the correlation as you move detectors apart. Alan Aspect in France, John Clauser in America, Abner Shimony, a whole crowd of people now started doing experiments. Will Bell's inequality be violated? And the answer is they are violated with quantum mechanics. And that means you cannot explain quantum mechanical these correlations locally. And I think that's the sort of summary, that's the position that is well believed in all...
I'm a layman. You tell me this, and I'm baffled.
I'm sorry, we were baffled when we saw it. Even when David Bohm and I were writing our book in about 20 years after we'd done the experiments, I had to say to David, are you telling me that quantum mechanics it's not satisfactory because it's non-local? And he quickly said, oh, no. But even he was feeling uncomfortable. And I must say, even I feel uncomfortable with this idea of non-locality.
Does this not hint to an underlying another order?
Absolutely.
I am baffled as a layman. What do the physicists say? If I go to a university, to a physics professor who knows a quantum physicist, I say, listen, there's this entanglement. What will they say to me?
They will say, yes, we agree with you.
So now how would they explain?
They will probably explain it, not in the same way as I explain it, because I've got the Bohm model, which a lot of physicists refuse to talk about. Don't ask me why. When I explain it to mathematicians and show them the maths we've done, they say, well, what's the problem? It's what we do in mathematics every day. You've just separated a complex equation into two real equations, and that's fine, no problem.
So what is that? How do they put into words?
They say, oh, it's quantum mechanics.
But how do they relate to reality? They don't care about that part.
They say, I've got an algorithm, I've got an equation which satisfies, which gives me the right predictions.
But that's mathematics. What about implications of it? What do they say? It's a philosophy.
That's not for us. That's philosophy. Oh, he's a philosopher. Don't want to speak to him. I'm sorry, that's the reality. Now, there are a lot of very eminent exceptions to that in the physics community and in the maths community. And if you go to talk to Roger Penrose, for example, he will know that there is non-locality there, and he is worrying about that non-locality. But he has a different idea of how to deal with it. And that is even scarier, because it says that the space-time as we know it is not the reality. There is something underlying it. I've called it pre-space. John Wheeler called it pre-geometry. And in that space, you can then talk about local relations. And I'm now really going into my own speculations when I'm talking about this. In other words, space-time is not a priori given.
Yes.
It's something we abstract. Where from? From this wholeness idea that I've been talking about.
Which is in line with what we're discussing today, isn't it?
Absolutely, yes. I think it was the realization that locality could be a relationship. Suddenly realizing that locality is not necessarily absolute. That really made me much happier with the non-local entanglement results that people are getting. And don't forget, the non-local entanglement, when I was first working on it, people were saying, you're wasting your time. We know physics is local. But then slowly, I used to go and lecture on this. And I used to start saying, oh, I'm very sorry, I'm going to introduce you to this idea of non-local. And when I started this, I got a lot of hostility. Then about 10 years down the line, I went to the same, so I've got to pretend, be careful now. Two young students in the front of the lecture theatre said, why are you pussyfooting around non-locality? We all know physics is non-local. Or we all know the world is non-local. So you see, there's, at least for that group, there had been a paradigm change.
But do those students think about the implication of what you're talking about?
I think some of them do, yes, some of them care a lot. Unfortunately, I remember one of the old professors sort of coming and going, why are they wasting their time talking about this? And I've never quite understood the dynamics of that, whether the older people felt... I think it may be because once you come into this holistic area, you're into almost religious type thinking.
Quite right, yes. We talked about that, yes.
And therefore people will think, well, what is he really saying? Is he really saying that there's some God who's actually intervening and doing these things? And I don't think that's right. No, I think we're faced with something in the laboratory which says there is something very strange going on here, and we have to try to understand what it is. And that's what a lot of people are also working on, trying to dig deeper on this.
Basil, could you go a level deeper now into the implicate order? Now, okay, we talked about that the external is a manifestation, it's only a 3D manifestation of, could be another part of reality where everything is whole. We use the holographic model to say that whole is ingrained in parts. Now, I am in the implicate order. What is happening there? How is there a life? Is there an organizing principle there? Obviously, we're now, what does mathematics say? What is happening on that level of reality?
I think it's not easy to say what the mathematics is saying without putting the mathematics down. I wonder if I could use some sort of analogy here again, illustrating this. This is going to be difficult. Wait a minute. Could you repeat the question just a minute? Because I've lost the...
I'm saying at the implicate level of reality, at the implicate level, if we go one, we talked about the fact that there's an external order, that what we see here is all ingrained, it's all unfolded from a reality that is whole. We'd use the holographic model that the total is in the regional, at one region in space. I'm saying in that implicate order, what is happening?
I wonder,
is there an organizing force? Is it interacting with itself? What is that doing?
It is really being, but let me try. I think I can try this. See, one of the ways of thinking about this was actually to think about the way we think about music, the way we appreciate music. What we find there directly is not that we hear a series of notes, rather that we actually get involved in recreating the theme as it goes along. We're making the past active in the present, and we're anticipating the future. Now, it's in that tension that we actually directly encounter the implicate order. Have you had that experience when you're listening to music, when you're sort of carried along without actually thinking about anything?
Yes.
That you become part of that. That is the nearest that I can give you as becoming part of the implicate order. So it's that ongoing process, that totality. You don't separate it out. So we can experience it directly, is what I'm trying to say. We cannot analyze it, because if you analyze it, you immediately are going to pull it into notes and so on. So what we've got to be able to appreciate is that aspect of the totality of that movement, of that flow.
Yes. So what you're saying is we have to be very careful. It's a process, right? It is a process. It's a process. We have to be very careful labeling and naming and all that, and defining a certain task. You're saying it's certain reality. It's not a reality. It's a process. It's a process, but a process from which we can become part of. Now, Basil, we talked about active information and how there is a new potential which acts at a very macro level, which has a implication about the trajectory of an electron, where it goes, and on the trajectory itself. Now, can you give an example where it highlights this, a contrast example? We talked about the two-slit experiment, which is very classical. But is there any other way, an example that you have in mind, that would show this, how an electron knows, or quote, knows, or how the field actually manipulates the electron?
Yeah, there is another effect which goes under the name of the Aronoff-Bohm effect, which I think highlights this particular point. As you say, we've got the two-slit experiment with electrons set up. And then what we do is we confine a magnetic field in the geometric shadow of the two slits. Now we can do this because if we have a solenoid that's a wire tube which has current flowing through it, if it's long enough, the properties are such that no field actually spills out into the paths where the electrons may be going. So in other words, this is completely in the geometric shadow, and the electrons going through the slits cannot possibly see the magnetic field.
So there is a slit, there are two slits into it, and in the center you're putting this wire which totally isolates the internal...
The magnetic field that is inside that.
So nothing escapes out of that.
No magnetic field escapes out of that at all. Now then, the question that, the point that these Aronoff and Bohm raised was, since this field is totally isolated from the electrons, we should see no change in the interference pattern of the electrons, whether there's a current flowing in there or there isn't a current flowing.
Because it's isolated.
Because it's isolated. But when you get the current flowing, what do you find? You find the fringes shift, so that the electrons somehow feel, if I can use that word, the presence of the magnetic field, even if you go to the extreme and put a superconducting film around it, because nothing can escape, no magnetic field can escape through a superconducting shield. Yet the electrons still change, and if you change the current flowing in that solenoid, you make the fringes shift more. They go to 2 pi and then they shift back again.
So the electron somehow feels that there's an electromagnetic field somewhere, despite the fact that that field is isolated and has no effect, no classical effect.
No classical effect at all, and it's not even clear what you mean by field, you see, because there is no magnetic field to feel. But nevertheless,
the electron
it changes its behavior in a way that we can only say it must have felt it in some way. Now, I was talking about the quantum potential earlier, and what one shows is that if you calculate the quantum potential, you find that is the thing, once again, which is responsible for the fringe shift. So this quantum potential actually has experimental consequences. It's the only explanation that one can possibly have of this particular situation, apart from the Copenhagen interpretation, which just says it happens, without giving any explanation whatsoever.
Yes. Copenhagen interpretation is not interested in explaining it.
No, in fact, I think one could even go as far as to say Bohr wanted to say you could not explain it. And he actually introduced a new principle in which he called it the complementarity principle of complementarity. And because of that principle, it is not possible to give a detailed description of what is going on.
Yes.
And that is one of the negative aspects of the Copenhagen interpretation that I did not like. And that's why David Bohm and I tried this alternative interpretation.
Basil, I'll be very grateful if you could zoom back again from this level of reality, if you could give a very short summary of, again, zooming back in again into the world, into the micro world.
Into the macro world.
Micro world.
Micro world, okay.
And explain, what are we, again, talking about the wholeness, and I'll be very grateful if you could just provide another summary. Let's fly it over it again. What are we seeing in the micro world?
In the micro world.
Yes.
Yeah, well, we've got two situations. First of all is the two-slit type of a situation that we've been talking about. Now, in a way, that's not quite as dramatic as the entanglement state situation. So let me take the two-slit experiment. What that says is that somehow information about the presence or absence of another slit is telling an electron that's not going through that slit but through another slit whether it's open or not. So you've got a kind of non-locality there. But that non-locality can be dealt with by saying that there is a field, an environmental field if you like, which I call the quantum potential, and it's that environmental field that feeds the information about the environment to the electron so that it adjusts its trajectory. So that's one kind of non-locality, and because you've got a field there, you can say the field is local, and therefore you can restore locality in that sense, because the field is carrying the information, maybe locally. The really dramatic effect is in entanglement states. That is when you get to atoms or to electrons or to photons, to light particles, and you put them in a very special state which is called an entangled state. Now I can't describe the mathematics to you, but just it's different. It's not as if the two states are independent of each other, they're coupled to each other in this particular, very particular way. They're not coupled by any force, it's just that they happen to be in this state in which they cannot be, their properties cannot be separately defined. Now, what you do with these is that you move them apart as far as you like without actually changing the entangled state. And then you do some measurements on one of the particles, and you find that the measurement that results on that particle depends upon the state of the distant particle, and in such a way that you cannot find any local way of explaining that effect. Now, that particular property came out of the theory that originally was proposed by David Bohm, and it came out very clearly because he was talking about positions of particles. But it actually traces back to the 1930s, when Einstein pointed out that there was something very peculiar going on here. Interesting thing is he never mentioned non-locality. What he mentioned was that we needed new elements of reality to complete the quantum theory. In other words, he was saying that the quantum theory was not complete. And Bohr said, no, it is complete. That was his answer to it. Apparently it caused Bohr a sleepless night. But he had the answer the next morning, according to folklore. And that was that he says that the outcome of these experiments depended very much on the total experimental situation. And somehow there was an influence, and no one has ever explained to me, and I've never understood what Bohr meant by the influence on the very conditions of the behavior of these two particles, even though they are separated by 32 kilometers. So now we've got this. This is the really dramatic thing. Einstein refused to believe it. Bohr said, yes, it's okay. Everybody else just took it without realizing what was going on. Interestingly enough, Schrödinger did know what was going on, and he wrote a paper just after Bohr's paper, where he introduced this idea, the entanglement is non-local. But very strange. Everything went silent. There were these 3 or 4 papers in the 30s, nothing more. Then suddenly David Bohm came up with his interpretation, which was known as the causal interpretation, and there was the non-locality staring in his face.
But was he aware of the Schrödinger at that time?
He was aware of Einstein, Rosen, Podolsky, I know that.
Yes.
It's not clear whether he knew the Schrödinger paper or not. Okay?
Basil, could you kindly tell how the journey in the quantum theory, just when Bohr saw these dualities, that the matter was both a particle and a wave, what was his reaction? What were the scientists at that time with Heisenberg? What did they come up with? And what did David Bohm knew? Where did he take on? Where did he come in and where did he take out through this whole history of quantum physics?
Well, essentially it was noticing that, or rather it was trying to make sense of what Bohr was actually saying. That's where the journey started. I think it starts with in all physics, you try to understand what the predecessors have actually been trying to do. And in the discussion with Bohr, it was never clear precisely what was meant by wave-particle duality. How could it be that a particle could behave both like a wave and like a particle at the same time. Because a particle, after all, is supposed to be some little object at a point, certainly less than 10 to the minus 13 centimeters in radius. Whereas to describe a wave, you need a wavelength which is of the order of millimeters. And therefore there seems to be a strong contradiction between those two ideas. The way Bohr got round it was to say that we have essentially reached the limits in which we can actually discuss the individual behavior. We have a principle of complementarity, which tells us that either we can know precisely where the particle is, and we don't know how fast it's going, or we know how fast it's going, but we don't know where it is. Therefore, can we find any concepts which will enable us to handle this idea? And Bohr's argument was no, we can't. What we have to do is to use the concepts of classical physics in order to do this discussion. So that meant then that there was no way of describing what was going on at a more fundamental level. So we had this classical description, which he said something about we need to be able to tell our colleagues what we have done and what results we get in the laboratory unambiguously. That was sort of implying that the particle, that the behavior of the actual phenomena, or the process that was going on, could not be described unambiguously. That there may be an ambiguous description. In other words, there was no precise image of what was happening and so on. And I think Bohr made it into a principle and said, we cannot find that because we've reached the limits of our of the classical domain. Therefore, what we were left with was some very inaccurate accounts of what is going on. For example, you find things like the cat is both alive and dead. And simply a mathematical formalism. And the thing about the mathematical formalism was that it worked. And it worked to a remarkable degree of accuracy. And I think people fell back and said, all right, well, if Bohr and Heisenberg can't tell us what is going on and they're telling us we shouldn't worry about it, maybe we shouldn't worry about it. Maybe we should just get on with the mathematics and deal with the mathematics and make the technology pay from there. And it's been tremendously successful. Don't get me wrong. That technique has been very successful. It has given us a lot of modern technology which is based on quantum mechanics. But when Bohm was trying to explain what Bohr was doing, he wrote a textbook, and at the end he felt, although he'd done the best he could at explaining what Bohr was trying to say, he felt that no, something was missing. He was not happy with what had happened. And slowly dawned on him that what was missing was any attempt to provide an ontology. I remember discussing with him, saying, well, all right, Bohr says we can't have an ontology because we don't have the concept, we don't have concepts necessarily sufficiently accurate to describe what is going on. So we went through a big discussion of how do we form concepts, are there such things as quantum concepts, and so on. Because we could see no limit why we should suddenly say there are only classical concepts and no other concepts. Could it be do something with the indivisibility? Maybe. But then Bohm discovered that if you rewrote the Schrödinger equation in a slightly different form without adding anything and without taking anything away from it, he noticed that you could get something which looked very much like classical physics. And this had in it one extra term from the classical physics term, the quantum potential. He then argued that, well, if there's only that small difference, and if that potential term is small, we would have trajectories. So when the term got a little bit bigger, there would be different trajectories, but there would still be trajectories. And there was no principle which said at some stage no longer can we talk about trajectories. And in fact, we then showed that you in fact could get a trajectory from the quantum formalism itself. And we explained such things as the interference effects that occurred via particles through this particular form. As we investigated more and more the quantum potential to see if we could understand what the ontology was that was lying behind this, so we developed these deeper and deeper ideas. First of all, the idea of non-locality through this entangled state that I talked about, the state where two particles can be separated in space, but in fact are not separate. It's a kind of togetherness yet apart. And therefore we started thinking about what this could mean. See, rather than what the earlier discussion had been, is there non-locality in this particular set of entangled states or not? The experiments had been done and it was quite clear that it was there, the effect was there, and you couldn't explain it locally. So then we started saying, well, you know, what sort of concepts could we develop in order to understand this process that is being thrown up by the mathematics? And this is where we came up to the idea that, well, we don't like the idea of the particle, because when we've got these two particles which are separated, what do we mean about them being a particle if we can't separate them even though they're separated in space? There must be something else involved in this. And so the idea was to say, well, maybe there's a deeper order. It's not an order of the Cartesian order, which are things following continuous trajectories in space and time, but there's a different order which was involved something much more general, some sort of topological ideas of betweenness and so on, without the necessary classical, traditional, Cartesian, Newtonian order. And that's when David came up with the idea that, well, maybe we should look at this more in terms of process. Whitehead already introduced this idea of process. And the other day I'd only just learned that one of the reasons why he introduced his idea of process was because of the problem that, this is a mathematical problem, that Russell and Whitehead got into about the set of sets. They tried to develop mathematics from a fundamental point of view and found they got into a contradiction over this, that the way they were defining the function would lead them automatically into this problem. And Whitehead's idea was, well, if we use the idea of process, then we can avoid this particular problem. And so his idea came then that we have process, that we have some sort of connection between two things, and we take that connection as primary, and that the separation comes when that connection breaks down. Okay, so now we've got the idea of connection as being taken primary, and it's a process. It's an ongoing process. It's like the process that I was talking about when we're appreciating music. The idea of connection has been taken primary, and it's a process. It's an ongoing process. It's like the process that I was talking about when we're appreciating music, where we appreciate the movement of that. So what we're saying is this fundamental thing is that quality. And what we've got to do is to try and develop a mathematics which has that quality in it. That was the way we went. Now, what I was able to do myself was to show that, in fact, it's very strange. I was talking about this at a seminar at King's College London. And I was saying that it seemed to me to be something like the way Grassmann was thinking. Gunter Grassmann was an expert in Sanskrit, would you believe it, but he's also developed mathematics, and he's laid some of the foundations of modern mathematics known as Grassmann algebra. But do you know he couldn't get a job in a university, even though he wrote this book, which defines all this new mathematics? the academics felt it was, it was too dangerous to let him loose in academia, and he had to become a school teacher rather than carry on with his research. Anyway, that's just an aside to show you some interesting sociology in new ideas in science.
Yes.
They're difficult to get in. But he had a very interesting idea that this guy who was in the audience said, "Why don't you read somebody's account of Grassmann?" So I went and read it. I was absolutely amazed, because he was saying that mathematics is not about material process unfolding in space and time. He says mathematics is about thought. Mathematics is about thought. Not the content of thought, but the form in which we can hold the content of thought. Now, for a physicist, that was mind-blowing, because I had always believed that what we were doing was doing the mathematics of the movement of material process in space and time. From those original ideas of Grassmann, mathematics was about thought. Mathematics, what is thought? Thought is about becoming, not being. And therefore, really, we should be talking about becoming and not being, whereas what we always do in Newtonian physics is talk about being. So being is a secondary. But what is more, he showed that that mathematics led to the mathematics that we're actually using in physics. But that idea of the process and the dynamism in that activity had been lost. And that's what we pounced on, and that's what I've been trying to... That's where the implicate order came from that idea of process. That it's a flowing movement, and that you don't divide it, but you take the flowing movement as your basic starting point, and then build up a relationship, a new order. And that order then had in it this idea of the explicate order. Because within that order, not everything can be made explicate at the same time. And this was very important. Bohr had a complementarity principle, which he thought was basic to quantum theory. That you could not say where the position of the particle was if you know where it was moving. If you knew where it was, you couldn't say what it was doing as far as movement is concerned. That had always been, in my mind, been sold to me because we're ham-fisted when we're in the laboratory and we disturb everything. Rubbish. The point is that nature itself is such that it is not possible in principle to define position and momentum simultaneously, because there are different aspects of this total underlying process. And it's from this mathematics that the implicate order emerges. And in that mathematics, the principle of complementarity becomes not an epistemological, but an ontological fact. And it's that which then motivates the implicate order. So the deeper order is not an order in which you can explicate everything simultaneously. And when you think about it, that's the way when we're thinking about thought. What am I doing with you now? I'm trying to explicate something which I have implicit in my thought structure.
Yes.
And it's very difficult, as
Yes.
to try,
Yes.
but to try and explicate in such a way that it reconstructs what I have implicate in me, in you.
Yes. And as an example, even in the holographic model, different angles of light produces different, so you can record different images on the same plate.
Yes.
If you shine different angles.
Yes, but you have to pick them out differently. You have to make them explicate.
That's right.
By using different
angles. Yes.
Yes, absolutely.
So the same space can actually explicate different forms.
Yeah.
This is where I can follow up your ideas.
Yes,
from
absolutely.
that example.
That's dead right. Yes. And then you have a sort of a 3 dimensions are all encapsulated. So the dimensionality of your space is even encapsulated in that. We had a word for it. Because everything came out of process, we called it the hollow movement. Now, Bohm introduced this idea of movement. I prefer the idea of activity, to have something dynamic which is moving. Carl Pryzdia, a neurobiologist friend of mine, said he doesn't like movement because it means something's moving. But Bohm had the idea of movement. It was much more general than that. We talk about the movement of a symphony, the movement of a symphony. So that's, nothing's moving there. There's a movement in the music. And so here there's a movement in the physical process. So all physical processes, movement is the hollow movement. And that, if you like, is the ground form, the implicate order from which the explicate order then emerges.
Yes. Now, Basil, going back from all this wonderful discussions, just zooming back again, as a human being that is contemplating, trying to understand my own mind process, I can now make a parallel between my own mind. I can now better comprehend what we spoke a brief moments back about if we make a comparison between the model of the consciousness and life and reality as it is. I.e., in real life we have atoms, which makes up this chair, me, the world, and the cosmos. And in my mind, there are neurons. They're factually existing material pieces. Then we gradually go up to the thought process. And I will use your word, it becomes more subtle.
Yep.
And in nature, we see that there's a kind of balance. We see that there's a kind of, there's organization principle somehow. That the DNA is structured by the DNA structures the reality, but is affected by the reality. So there is this movement. So you feel that there's a dynamism, that somehow there's an organic feel to it, to the whole.
Yeah.
Now, we're going to the thought, and we're going deeper. And I realized one thing, that the most subtle form of existence in my own personal experience is when I am at a stage where I have a more silent mind, when I experience silence. That is not a noise silence by noise, physical sound, but it's a silence when I feel, when there is no thought process going in my mind, so I'm just without worrying about tomorrow, without yesterday, just being at this moment, just being. That is, no thoughts are moving. At that stage, somehow, I can say from my own experience, because the feeling of I, as Taher talking to you, because I is also a thought. What we fail to understand, that I is a thought. I think that I'm thinking, but as soon as I say I, as soon as there's a thought, the word I is a result, it's a product of a thought. So when all that ends, then I can understand the concept of wholeness at a level, well, intellectual understanding of the fact is what we've been trying to do.
Yes, yeah.
But it seems like we talked about implicated order as a very subtle order, and as it comes to the explicate, it becomes more explicate, more tangible, more manifest.
More tangible,
and then
yes.
I feel that in my own experience, that state of silence is a very, very subtle level. It's a level of pureness in which one could almost say that one, now a question, and I feel that one is closer to reality, because any thought is a material movement of neurons and fibers.
Yeah.
Once you are able to sit in silence, when you're able to experience silence, then you're into a more subtle level, which is closer to the implicate order. So just this vision arrived at me. Imagine human beings like black holes, you know, where there's this 3 dimension, and we're just like this well, this well, that from this explicate order, what is special about having this consciousness is the fact that we're aware that we're there. But if you could do that without this fragmentary process of thought, without the me seeing that, just knowing, then it's like every human being is like a micro vortex, shall we say, that comes down and probably touches the implicate order, that somehow is in direct communication with the implicate order. This is just a kind of a picture, of course, and I recall what you were saying to me again and again, that all we can discuss is images which are not the reality, and I'm very cautious, but this is the kind of images and metaphors that come to my mind. What would you say about this?
No, I think you're right, actually. I mean, One of the things I'm envious of you of is that you can actually reach this stage where you can empty your mind. David Bohm and I used to have this game because he always used to say, yes, we really must empty our mind, and I kept screaming at him. But every time I tried to empty my mind, it becomes full of thoughts. And it seemed to be the opposite of what one wanted to achieve. But there are moments when usually when your mind and your attention is distracted, that you see something in the background which makes you sort of feel something, that you are, as it were, in touch with some deeper reality. And it's very difficult to articulate that meaning. Maybe we're talking about the same thing.
Absolutely, yes.
When we're talking about that.
Yes.
But all I know is that my mind is very noisy. Very noisy. Even now I've got words shrieking at me from all different directions.
Yes. You see, so that when there is the understanding that every thought is an explicate order. It's from the explicate order. Every single thought. Now, I can sit down with you and say about... Please.
No, I think I've just, as you're talking there, sorry to interrupt you, but I've suddenly thought that, to me, the time when I feel I'm in touch with that kind of reality is when something dawns on me. When I've been struggling with, say, some mathematical formula. I'm making this rather trivial, but... And then all of a sudden, I suddenly say, oh my God. And in one flash, this disjoint structure suddenly fits into place. Not in a way that all the parts are explicate, but there's some deeper structure has suddenly clicked into place. And I always feel that that is where one has begun to touch the implicate order, to touch this deeper order, that one suddenly sees all the different manifestations of it without actually having to display them all simultaneously. And I think those are the moments when, but they're not quiet for me. They're just some sort of tremendous experience of elation, of joy. I mean, I've even physically moved by jumping out of my chair once. Oh my God, is that what it is? Maybe that's the different experience. I don't know.
Yes, you know, I see this in my own reality.
I don't know.
Yes, you know, I see this in my own reality. For example, people who love what they're doing because they enjoy it. For example, I know businessmen who actually, we're all, in a sense, we're seeking silence by what we enjoy to do, in a sense that...
I would say we're seeking coherence.
Coherence, yes.
That would be a better word for me, because that's what I was trying to get at.
Coherence, yes. You see, I know businessmen who, when they listen to somebody who is talking something interesting to them, I come from the business world,
Yeah.
they listen with absolute attention. And at
Yes.
that moment, they're silent. And there's this coherence in their body.
Yeah.
And this is how they experience coherence. But when they go back home, they're not interested to what is there. They're not interested, let's say, in their children or to whatever it is.
Uh-huh.
So they look forward to come back to the office, to sit down and do that thing which, so then we call this workaholics. And
yeah.
then, so we all seek silence, in coherence, let's
Coherence
say.
is what I would say.
Yes, in things that we do, because once something draws our attention, then, you know, we are close at that stage. Whereas, of course, my own personal life, because I've observed a lot of fragmentation in the world, I've suffered from it. I have traveled through many geographies. I was born in Iran. I lived in Turkey, and I'm in Azerbaijan. I lived in Europe and Middle East, and so I started a journey of understanding what is the thought process. What is it that I'm thinking, and it's not a. There is actually the word enlightenment is actually it's a very misleading word, because you think it's a moment. It's not a moment of enlightenment. Yes, it's that moment is the manifestation of an accumulation.
Yeah.
So it's not. So we got this thing that I'm enlightened suddenly, but there's a lot of thinking and a lot of factually analyzing the mind and the nature of the fragmentary nature of mind that brings you to that moment of silence. So once you know that you can think of God, I can sit down here and say, well, God is infinite. But what I've just done is a material process.
Yeah,
Neurons are
yeah,
fired.
Yeah, yeah.
Now, I can sit down and say, close my eyes and say, implicate order. Once you know, there's no use.
Mm-hmm.
Because that's
No, like you've explicated it there, yes.
finished. So
Yes.
you're not there.
Yes.
So,
So therefore you have to live the life. You have to live the implicate
you're
order.
just learning, just understanding this fact that whatever you think, whatever you know, as soon as you have knowledge, it's memory, and it's a physical memory. I feel it in my body, actually, Basil.
Mhm.
I feel different memories. Memories, I'm not a scientist, but are physical storage. It's like when you store the information in the computer, there's a physical change.
Mhm.
I know memories and traumas are physicals.
Right.
As soon as I have, let's say now I have a knowledge of wholeness after this discussion. If I act from that knowledge, it's explicate.
Yes, yes.
So the only way for me, the paradox is, to understand what we're talking about, is actually to forget about all this, for all this to have no significance whatsoever. And yet, what we're discussing here is because we in the Western world, and I say this, anybody who is into science, I think what you're saying to me, if you tell me, Taher, what do you perceive from what we've spoken? What you're saying to me is, and now I sympathize with Bohr. He says, we are at a very strange location. And Bohr's famous sentence, we're suspended in language.
Yes. Oh, yes. Yes.
And I'm saying we're suspended in our thought structure.
Mhm.
So just by being, because even Bohm, I'm sure, and you mention it very quite often, these are all models.
Yes. Yeah. Yeah. Sure. Sure.
I can't say,
But it is to be aware of this underlying deeper movement that we're trying to bring to everybody's attention.
that is right. That is right.
Because the noise is going on so loudly in here that we don't appreciate. We don't realise it's going on underneath.
That's right.
And the hope is that by making that, bringing that to the fore, to pay attention to those subtle movements, is where one hopes that one will make progress.
That's right. So what you're saying me is, from this macro level world, there is an internal world that is all, it's the wholeness that is a primary reality.
Yeah.
And then we made a parallel with the mind, and I said, whatever I think is explicit, is neurons. So is there a stage that I can experience this wholeness? And I realize it's only by quietening my mind,
Okay, in that
by
sense,
being
yes.
silent, can I go to the
Yeah, yeah,
implicate order.
yeah, yeah.
So
Okay.
what I feel from at the end of this discussion is, what makes us human beings as unique creatures, from, of course, I won't say the cosmos, we don't know if we're alone in there, that's another discussion, which is not relevant, but what makes us enormously valuable, as it's quite interesting to see that the cosmos, how it evolved, let's say, if we assume from a Big Bang, to a point where it comes to human being, and our biggest capacity, the biggest intelligence we can arrive at, is silencing ourselves and just being, so that the universe could be back in touch with this implicate order.
Right.
So there's this circle now with the human being. That circle is completing.
Yeah. I would like to think of it as a spiral.
Spiral, I
it's
apologize.
No, but it's moving
Yes,
on.
yes,
even
yes.
though it comes back
Spiral, yes. So that is which I find it. I think physics has the potential to, because nowadays we're all listening to the scientists. You are now our gurus. Before it was a religious, it was a church, it was the mosques and this and that, what they say. Well, in most of the world still that is the case, but in the Western world, let's say in the more academic world, and what defines reality and media and society is now the scientist. But I think it's a great tragedy that scientists are as fragmented as a layman, as divided as they can't see the totality. It's like a politician not being aware that his actions has an implication for the society.
Right.
Imagine a minister that is not aware that he's affecting his society. So it's a tragedy that I'm a layman. I'm fascinated by what you're saying, and just like the most beautiful piece of art, I feel like I'm a different person now than I sit with you in the beginning. I think it's I can't believe that another physics professor or whatever would see this and say, well, actually, Entanglement, yeah, there is, but so what? You know, that's a technical thing.
I have great hope in the younger generation. They are the guys who are taking hold of these ideas and going to push them on. I think the older generation we will never change them somehow. It's the youngsters. They're our future. They're our future.
And I hope that what we're doing now can just be an inspiration, a starting point for them to say, well, you know, I'm going to go beyond my shallow, small life and see that every thought that comes to me, that my whole life I'm living in this explicate order, all these little problems and worries, and I'm going to think deeper and be inspired from science. So we're saying, let's be realist again.
Yes.
But the paradox is, being realist calls you now to think wide, to think holistically.
To think holistically.
Because that is realism.
Yeah.
In fact, now mysticism, which if it's a cloud, if you call, David Bohm used to say mystic, it's being like in a cloud, it's like being hidden, like mysticism is like hidden. I think we're clouded and with this fragmented idea. I think we should come back to science, and quantum theory with its new concepts can give that push to us to say, wake up guys, you know. And I think it should be taught in every single high school. I think it's the biggest crime against humanity. You know, they tell the chimpanzees are the crime against chimpanzees, or the nature and the environment. And I think at the fundamental level, we could change this by education. And I think that we should go back to high schools and say, listen, we've got to look at this physics that we're teaching to children and wake them up and put these models into it. What do you think about this?
No, I agree wholeheartedly with you. And I think I'd like to end there.
Thank you very much.